Good afternoon. Thank you for joining us today for our presentation on roof system selection for food manufacturing and healthcare facilities. I am Jennifer Steffen. I'm a senior roof consultant with Benchmark. I've been with Benchmark for about 6 years now and in the roofing, building envelope, and construction industry for over 25. I primarily write specifications and prepare design documents for roof refurbishment and replacement projects. And joining me today to present is James Santiago.
Hey, good morning. I'm James Santiago. I'm a senior consultant with Benchmark. I've been part of the team since 2016 with industry experience dating back to 2012. When I first started with Benchmark, I provided construction phase services, providing oversight on construction projects for compliance with the bid documents, and eventually transitioned into surveys and design along with some client management.
So really briefly, we just wanted to share with you a little bit about Benchmark and who we are. Benchmark was established in 1983 to provide consulting services for roof and pavement projects. We are an independently, privately owned company with offices located in Cedar Rapids, Iowa, Waukesha, Wisconsin, and 29 satellite or home-based offices. We have 118 team members, including our field staff, designers, and project support teams serving projects across the United States, Canada, and Mexico. We primarily provide 5 types of services. We've got our evaluation or assessment of existing assets, design, bid, and for refurbishment, repair, and replacement scopes, construction phase services, quality control and quality assurance, and program or portfolio management with our SiteMan database. We also have a UAV drone to provide imagery for our projects. So it probably goes without saying that the roof's primary role is to keep water out of the building. Sounds simple until we start talking about all the other things we expect the roof to do for us. It can be a very difficult puzzle to design a roof to be long-lasting and watertight with all the other functions we need it to do. In addition to covering the fundamental selection criteria today, we will also talk about service life, ease of install and repair, and other options that come into play. We plan to focus on the food and healthcare industries, but we'll also speak a little bit about the other categories that we discussed on our poll question. We're going to first take a few moments to do an overview of roof system types so that we have some common language and foundation to talk today. Then we'll talk through the different criteria used to select a roof system. It's important to keep our target in mind throughout the entire selection process. The goal of any roof project is to design a roof system with optimal durability, longevity, and operational efficiency, which ultimately aligns with your corporate objectives and budgetary considerations. James is going to take us through some of the most common types of roof systems and membranes.
All right, so the first roof system type we have here is EPDM, which you may know as ethylene propylene diene monomer, or more likely just rubber. EPDM roofing membrane was first introduced in the 1960s. It's typically installed over coverboard and or insulation boards. It's available in black and white options. The sheets can be installed mechanically or with adhesives, and ballasted assemblies are also available. Seams are adhered and cannot be hot air welded compared to some of our other roof systems. One of the benefits of EPDMs is its ease of repair, being able to perform repairs with cold applied materials and not requiring any special power tools. All right, so next we have thermoplastic roof systems. The roof systems which fall under this type are PVC, KE, and TPO. Thermoplastic roof systems are typically installed with the coverboard and or insulation board. It's available in white, tan, gray, or specialized custom colors. Sheets can also be installed mechanically or with adhesives, and ballasted assemblies are available. The seams on this membrane are hot air welded, unlike EPDM. One of the benefits of thermoplastic roof systems are its resilience to ponding conditions due to its hot air welded seam construction, though the repair methods do require special tools, and those tools will need a power source. We have a mixed variety of introduction dates into the market, with PVC being introduced in the market around the 1960s, KE being introduced in 1979, and TPO around 1989. These single-ply membranes are widely available and can provide lasting service for food manufacturing and healthcare facilities. Next up, we have our modified bitumen roof systems. Modified bitumen roofs are asphalt-based. Mod-bit roofs are typically installed over coverboard and or insulation boards similar to the previous systems. The sheets are installed with adhesives or can be torch applied as well, though not as common due to risk. Seams can be sealed with adhesives or welded. Typical finish on this membrane will be granule surfacing, or you'll find a smooth finish with an aluminized coating or some sort of coating application. Modified bitumen roof membranes were first introduced in Europe in the 1960s and made it over to Canada and US around 1975. Modified bitumen roof systems are a bit more robust than single-ply roof systems, as it contains multiple layers adhered to form the roof membrane. And next up, we have liquid applied roof systems. So liquid and spray applied roof systems include spray polyurethane foam, elastomeric systems, and silicone systems. Liquid applied roof systems can be used as a new roof application or a recover application. These roof systems are monolithic, which means it's one continuous layer rather than multiple sheets seamed together. And next, we have metal roof systems. Metal roof systems are either architectural or structural, with architectural metal roofs being installed over a solid piece of decking, typically plywood or OSB. And structural roof panels are, well, structural in nature with no underlying decking. Metal roofs are typically insulated from the interior with batten insulation and a plastic vapor retarder, or they contain no insulation on the underside at all, which is typical for any unconditioned warehouse space. Metal roof panels can be secured with concealed clips or exposed fasteners as structural supports, and they're mechanically attached and sealed at seam with butyl tape or sealant. Although not as common for healthcare facilities, many food manufacturing plants have building protected by metal roof systems. Whether through fastened or standing seam, the metal roofs provide a long-term protection for production and warehouse spaces. Other notable roof systems include, though maybe less common, are shingle roofs on your commercial property, aging CSPE, or coal tar pitch roof systems. We aren't seeing as many of those anymore as the older systems have been replaced. And to visually encapsulate some of our discussions, we've attached a roof membrane attachment chart here. As you can see, there are many ways to attach various roof membranes, but by far the most common are going to be adhesive and mechanical fasteners. And you'll find general roof membrane attributes on this chart. I would like to note that individual manufacturers have specialized sheets that can improve certain attributes. Also, increased membrane thicknesses can improve attributes like durability and service life. For any box with the orange dot indicating marginal performance, those criteria would need to be carefully considered before selecting a roof membrane for that roof area. For example, EPDM may not be the best membrane for an extremely high traffic area on the roof. You also see we have left out rating on durability and 20+ year service life for TPO membranes in particular. We just felt it would be unfair to label this as either acceptable or marginal, as it doesn't have the same level of history as some of our other products, and quality may vary between manufacturers. I would like this to be more of a to be determined rather than a negative mark. Two common questions stemming from this chart would be, what membranes have the longest track record and what membranes would have the longest service life? Well, when it comes to the longest track record, we're definitely looking at modified bitumen roofs, built-up roofs, and metal roof systems. When looking at the longest service life, similarly, we're also looking at modified bitumen roofs, asphalt, and/or coal tar built-up roofs, which you may not see much anymore.
So now we're going to get into the meat of our program. Which membrane should you use, or which system should you use? If only it was as simple as selecting one based on membrane attributes, our job would be very easy. But there's a long list of criteria to consider. Some of the criteria are optional and others are required. The easiest place to start is always with the requirements, and then work down the list in terms of client priority or wants. Sometimes insurance requirements will take the next priority, sometimes budget, sometimes schedule. Sometimes it's leaks that impact production that bring the roof or the system right to the forefront. It all depends on the individual client and the location. So let's talk a little bit about the requirements. Building codes define the legal requirements for each location. It's interesting to note that across the US, some areas are still using the 2009 IBC, while some have adopted the 2021 version. Yet, as you can imagine, the requirements vary significantly between the different versions of the code and local amendments that might be adopted. You can see here just a couple of high hitters: Miami-Dade County for Florida, Title 24 for California. Those are going to have much more stringent requirements or different amendments than, say, a county in Missouri. Let's talk wind for a minute. As we focus on the roof to keep the water out, there are several forces of nature that works against us. Wind is one of the primary ones, and it's also one of the primary causes of failure for roofing. It's important to make sure that your roof will hold up to the normal environmental forces that happen at your site, including weather events, typical storms. We recommend working with a design professional to calculate the wind uplift pressures required by code and your insurance company.
And here we just have another example of failure at the inside corner of the roof system. You can see where the membrane has pulled away from the walls where it meets the brick, and it's exposing the underlying system below.
Fire resistivity is another code requirement for roofs that was born into code after the 1953 GM Hydromatic plant fire. This plant outside Livonia, Michigan was only 4 years old and was state of the art for its time. There are a lot of theories about how the fire started, but for us in the roofing industry, the key takeaway was that the roof, a built-up roof, asphalt roof system on a steel deck, actually contributed to the fire as the asphalt melted and released tons of liquid molten asphalt into the building, fueling the out-of-control fire. This event was part of the stimulus for early code additions requiring UL testing for roof components and separation to slow fire spread, to allow people time to evacuate and hope to contain the fires.
All right, so drainage is really the silent partner of the roof system. As we mentioned earlier, one of the primary functions of the roof is to keep water out, but it also needs to manage all of that rainfall and snow. In this slide, we've provided a typical tapered insulation layout, and as you can see, it can be complicated. This is another example where working with a design professional can really help. If you rely on contractors to provide designs like this, you may miss out on providing efficient drainage layouts. On roof replacements, remedying poor drainage can be accomplished by adding tapered insulation panels and frickets, but for some projects, drainage can be extra challenging just due to flashing height limitations and roof obstructions. The goal is to try to move water off the roof, but in reality, every roof ends up with some areas that drain slower than others. As you can see in this photo here, we have some ponding conditions still relatively light. Despite all efforts, small puddles of areas in ponding water naturally occur. Some membranes and systems have characteristics which are more resilient to ponding conditions. Ponding conditions can accelerate the effects of UV exposure on the roof system, as it can act as a magnifier of sorts. Ponding water also tends to collect debris and dirt, increasing the chance to obstruct drainage outlets. Although not a code requirement, designing for hail resistance is an insurance carrier requirement for FM Global, Global Risk, and AXA XL insurance. Requirements for levels of hail resistance are based on your geography, or the site geography. It's simply good practice to design systems to withstand weather normally anticipated at the project site, whether or not it's required by code or the insurance. And here's an example of the hail map provided by FM. Numerous assemblies are available within the FM Global testing database for severe and very severe hail ratings. Very severe hail is defined as hailstones larger than 2 inches in diameter. Generally speaking, most assemblies will provide a moderate hail resistance. And here's another example of some hail damage caused on an EPDM roof. Without a cover board, single-ply membranes just cannot withstand large hail strikes that come with severe or very severe hail events. Damage like this results in catastrophic failure of the roof system, resulting in costly emergency repairs or replacement.
So we've talked about some of the most common code requirements. We skipped over thermal requirements. The energy codes do prescribe the amount of insulation that needs to go in a replacement roof or a roof recover. Not very many exciting slides to present about thermal insulation, but it is another code requirement that must be considered as you look at different systems. Let's talk some about the unique criteria for many food and healthcare manufacturing plants. Some of the challenges for your roof projects are that there are no breaks in occupancy or production for food and healthcare. You run 24/7. There's no downtime. Your interior activities are highly sensitive to dust or debris or odor infiltration, and you oftentimes have open food conveyors or open surgery suites below these roofs. You have some extreme temperature applications within the building, sometimes room to room in the same building. And there's a much different design for a -10 freezer than there would be for an office space or an unconditioned warehouse. You also have typically high humidity areas, washdown areas, ovens, cookers, kettles, process areas, showers, therapy pools, all housed within the same facility or building. Many of your facilities also have chemical discharge onto the roof with fats, oils, and greases. Some of these chemicals released are the natural solvents for roofing membranes and adhesives, or are highly acidic or caustic and will actually cause severe damage to the membrane.
Here's a photo we have of some chemical discharge. So not only can chemicals be harmful to our health, but chemicals can actually cause cohesive membrane failure, resulting in the release of plasticizers from PVC or TPO membranes. It can also cause microfractures in the roof membrane due to extreme temperature changes. And here we have another example of contamination on the roof system. In general, contaminants can greatly reduce the roof system's life. Some items to consider include whether you can install a containment system around equipment, or is this a location where a mechanical scrubber can be utilized?
And what do you need to do for that drainage as well? Does it need to be prevented from entering the storm system, or does it need to be treated in accordance with the EPA guidelines before it can be released into the storm drain system? There's a lot of considerations that go into how to treat the chemicals as they actually drain off of the roof. As we mentioned a few minutes ago, the temperature variations for freezer and high humidity operations presents unique challenges for food and healthcare manufacturing plants. Refrigerated buildings tend to have strong outside to inside or warm to cold vapor drive. As you see in the infrared photo here, we found an air leak along the exterior wall where 62-degree air was entering a 32-degree cooler room. Part of the roofing project was to seal and remedy this thermal break at the exterior wall. High humidity areas have the opposite vapor drive, inside to outside, which can cause extreme wetting, mold growth, and deterioration wherever that warm, moist air travels to escape the roof or the wall. Another factor unique to many food and healthcare facilities is the tendency to place most, if not all, of the air handling mechanical systems on the roof. All of that equipment needs to be maintained monthly or sometimes more frequently, which causes a lot of foot traffic on the roof. Some roof membranes are extremely slippery in wet or cold conditions. Will walkways be needed? What kind of safety do we need to include in the roof project? What measures are in place to keep those workers safe while they access this equipment? Another unique characteristic of many food and healthcare facilities is expansion. Many facilities have been built up slowly over the last 30 to 75 years, meaning there are newer areas, newer buildings attached to older construction. The new roof systems are expected to facilitate and accommodate that thermal and structural movement of the building, both new and old, and still keep the water out.
Emergency room doors are always open, and healthcare never stops working. Likewise, to meet the demands of the hungry masses, most food production facilities are running 24/7. This drives some companies to select roof systems that are going to minimize interruption both during the initial installation and over the life of the roof system.
So it's important to consider, what do you need to include in your roofing project for interior protection? What is it going to take to maintain this roof? How much odor will it cause as you repair it? How easily can it be modified in its future life?
So now we're going to kind of go into service life and maintenance. With all the conflicting priorities facing many facility managers, sometimes roof maintenance falls to the bottom of that list. Selecting a roof system that's going to provide adequate performance with little maintenance over the longest period possible is often the best step towards reducing future problems. I encourage you to think about your current maintenance program in place and whether you even have a maintenance program in place. If not, it's something you should consider. When we hear the word sustainable in our industry, we normally think about products when they're first installed and when they're removed, but there is a space in between there. Sustainable maintenance practices can assist in maintaining your assets for longer periods of time, not only deferring replacement, but reducing your impact on the environment. This is part of what helps us. Determining ease of repairs and preventive maintenance is another aspect. This is what helps us in kind of guiding. Since maintenance is unavoidable, taking into account whether the system can be easily repaired is important. If we have equipment and outlets which can be utilized for service contractors on the roof, they are more likely to hot air weld a patch on a PVC roof system compared to performing an improper repair. If the roof system has no means of access, clearing drains and performing preventive maintenance is less likely to be done.
So we've covered the common types of roof systems and some of the important criteria for selecting a roof system. Now we've got a couple examples here so we can talk through our thought process as we select a roof system. I'm going to put James in the hot seat first.
All good. Let's see. So we have a scenario 1 here. So on these next few slides, the facility, we have a food production facility located in southern Texas. The facility manufactures fried snacks, and as you can see below, towards the south side of that picture, we have some grease containment systems which haven't been too effective. And working with the owner, it was determined that rooftop traffic was moderate with equipment that requires maintenance and periodic repair. As previously noted, there is a severe level of oil discharge on the roof membrane. So due to the increased risk of damage from oil contaminants, we recommended the specification of an adhered KEE membrane system. The roof membrane provides a superior resistance to numerous chemicals, greases, fats, and environmental contaminants compared to typical PVC and TPO membranes. And the off-white membrane helps provide ultraviolet resistance. This is specifically important. We also specified a reinforced membrane compared to a non-reinforced, which is specifically important due to high foot traffic and equipment maintenance. As the client was FM insured and under a very severe hail rating location, the membrane was paired with an adhered gypsum coverboard.
Very good. Our next scenario is a hospital in South Florida. As you can see, this area to the top of the photograph, a very old aluminum coated smooth surface modified bitumen roof system. This location is under the 2021 IBC and under the Miami-Dade requirements as well. To further make things a little bit more complicated, they are FM Global insured. So not only did we have Miami-Dade and the newer code, but we also had FM Global requirements to meet. This is an operating room beneath this dark area of the photograph. And the work was only allowed to occur in the evenings, at 8-hour shift each night as they shut down the operating room for us. They did not have any tolerance for dust or any infiltration of debris and needed full interior protection after we found that the deck was deteriorated. It was a gypsum deck with a lot of water damage. The main access point for the hospital was actually on the left side of this dark roof, which accessed about 40% of the hospital facility. So not just this roof, but a lot of foot traffic crossing this roof to access all of the mechanical equipment on the rooftop and adjacent roof systems. The owner was very familiar with modified bitumen roof systems. So when we asked them what type of maintenance program did they have, they said that their most common type was the modified bitumen and that was what they were used to repairing and taking care of. 3 of the sides of this roof are bordered by modified bitumen roofs, some newer, as you see in the bottom of the photo, and some just as aged as our operating room. So when we looked at what would be good options for this, obviously we could go back with another modified bitumen. We could propose a PVC roof. We could propose a KEE roof. In the end, we ended up going with a very robust 3-ply modified bitumen roof system that met the wind uplift criteria of the South Florida requirements for Miami-Dade and for the FM Global. Next scenario, I'm up again. We have a food manufacturing plant in Missouri. As you can see in this photograph, this area, the top of the photograph there, long-wise, is a overproduction and a cold storage or cool storage area. It had numerous repairs over its service life. It is a modified bitumen system now that has been leaking and they've been trying to repair it for years and years. This facility is under the 2009 IBC. They are FM Global insured, and there's a requirement for very severe hail rating in this area of Missouri. The occupancy, as I mentioned below, is an open product line with the continuation into the cool storage, so pre-freeze, so cooled storage area. The ceiling below was exposed to the production, so there was no drop ceiling, there was no interior paneling or anything to protect the production line. We ended up having to propose or going with a full interior protection system to protect that product line from falling debris or dust. The client wanted a 25-year roof system. Actually, they really wanted a 35-year roof system, but a 25-year roof system, and they have a robust maintenance program in place. Most of their experience in their maintenance program was with modified bitumen roof systems. They have some chemical fallout that happens at this roof from nearby stacks that exhaust some raw product onto the roof. That raw product, it comes in a powdered form that actually was causing the granular loss of many of the modified bitumen roof membranes on this area of the plant. Two sides of this roof border aging modified bitumen roof systems. So when we looked at the proposed roof systems, we looked at the modified bitumen similar to what they have, but with that fallout or that powdered fallout that we were getting across this area of the plant, we wanted to add a little bit more protection for this roof area. So we actually proposed a hybrid system, a modified bitumen base sheet with a KEE cap sheet. And that's actually what they ended up doing to protect that modified bitumen from that powdered fallout that was occurring.
All right, in this scenario, we have a pharmaceutical manufacturing facility located in Virginia. The rooftop equipment here is mostly fresh air vents and exhaust fans with some HVAC equipment scattered throughout. The site experienced some recent hail damage on some of their older TPO and CSV roof systems, and they are FM Global insured. So this site was unique in the sense where they operate 24/7 and they will not shut down for interior protection. So they tend to perform their large replacements during an annual shutdown, which is a 2-week window. On this particular project, we partnered up with the contractor and had nuclear moisture survey performed on the roof area. The nuclear survey was performed as the current assembly has 2 roof systems in place, and the nuclear survey can accurately detect moisture penetrating on the underlying sections as well as the upper portion of that roof area. Once we determined the areas of saturated roof components, we had the areas outlined and provided a scope of work to remove and replace the wet areas during that 2-week shutdown window, along with installing interior protection. Once that work was performed and the wet insulation was replaced, the contractor will install an elastomeric coating over the residual roof area. The installation of the elastomeric coating won't disrupt interior operations, and it's performed at the surface level. Because they are FM insured, it also required an improved coating assembly.
Awesome. Thank you, James. So we have time for a few questions. It looks like we're fast talkers, so we actually got through that in good time and allowed enough time for some question and answers. So if you have some questions, so it looks like we have a couple that have come in. Mr. Andrew says, can you please share best practices to protect the roof during construction process, i.e. piping, stands, HVAC units, foot traffic welding after the roof is installed? James, you want to take a crack at that one?
Yeah, if we're talking about an area that's going to be traversed during construction, I know one thing we do is we set up insulation and plywood kind of walkways or ramps between those common walked areas. That'll kind of help, really setting up a controlled access and a controlled path where they're really not going to venture beyond a certain area. That really helps limit your damage and kind of limits construction damage in general.
After the roof's been installed and they pull off the project, we oftentimes will ask people that as one of the last steps of our punch list, where would they like walkways or roof protection walkway paths? Similar to the roof protection that we specify for use during construction, these roof pathways kind of provide a prescribed walkway or pathway that you'd like people to take to access different areas. There's different levels of walkway protection. Some people use just the manufacturer's walkway protection, and that's enough for the typical maintenance workers. If you've got a lot more like rolling carts or things that are traveling across the roof, it might be best to look at a more robust system, maybe a raised walkway or a raised platform from a pre-manufactured Miro or PHP type of system, or even a paver type of walkway that would provide a prescribed path for those rolling carts and other things that need to travel across the roof. I've got one more question that has come in. Mr. Mark says he's familiar with infrared studies to determine wet roof areas. Please explain the nuclear studies further if you could.
I don't know if I'm the best to answer that, but on this particular site, the nuclear study, pretty much it's just above. It can kind of take a depth of the moisture scan. So it's above kind of a typical Tramex where it's really just surface level. So this particular instance with having two roof systems, we knew the upper level of the roof system would have some wet insulation, but also what was that level on areas, beyond that kind of first layer of roofing essentially. So the nuclear survey will be able to identify, pretty much they gather parameters and they come up with kind of their number-based system on the level of moisture, and it kind of can go further in depth and find a deeper depth of wet insulation.
As its name suggests, it actually is looking for the nuclear composition. So it's actually looking for the hydrogen within that system. So it's looking for those hydrogen molecules and detecting that level. Nuclear surveys are often completed while the plant is shut down, or areas of the plant are shut down. Many times they cannot be performed with people underneath, depending on your roof system or your composition. So that's important to note that nuclear scans do require some coordination to approach that while the plant is shut down or areas of the plant are shut down. As James mentioned, it can get to a deeper depth, so you might be able to detect moisture in an underlying roof system that you wouldn't see with infrared or with capacitance meter. We've got Mr. Eric who wants to know, what's the best roof system?
Let's see, best roof system. For me personally, I'm a big fan of metal roofs and coal tar pitch, though you won't find many of those being installed due to the risk and the lack of experienced labor. But tend to see kind of long lasting, and metal cannot, sometimes it's not aesthetically pleasing to have a metal roof, but that's a personal. How about you?
I don't know that I have a favorite. I think every roof has the right application and the right chance to really shine if it's given the right circumstances. So I think I like all roof systems for different reasons and different applications. A lot of single plies, a lot of PVC and KEE out in the marketplace for good reason. A lot of modified bitumens out on the marketplace for good reason, provide good lasting service. But I think there's a time and a place for almost every type of roof system.
Yeah, I agree.
Mr. Alley or Miss Alley says, what type of protections are available where equipment is operating below and decking, and we need replacement of the decking overhead? Interior protection systems can vary. I have personally been involved with projects where we've been able to use just a simple 6 mil type of polyethylene sheeting, and that's been adequate to protect the equipment below. I've also been in situations where that wasn't adequate, and we ended up with full scaffolding type of protection to protect the very sensitive equipment down below, or almost setting up a plastic clean room beneath that overhead scaffold protection. So it can range anywhere from as simple as plastic draping over a piece of equipment to protect it very temporarily, to setting up full interior rooms with plastic protection to create clean room environments. How about you, James? Anything to add on additional types of protection?
Yeah, there's interior protection platforms, but I think you kind of touched on it as well. Just, there is a variety of options available to make sure, your equipment is safe. And, there's debris netting and kind of various options.
Various levels. Yep. Mr. Brian says, my roofs are in a paper mill with heavy chemical exposure. Are we in a hurricane area? What is the best roof system for our application? Have you done a lot of, I'll take a stab at this one. I've done I don't know about quite a few, but at least a dozen. And I know some of our colleagues who are on the call in the background have done dozens and dozens of roofs for paper mills in hurricane zones. From my experience, we typically go for the more robust, like a modified bitumen roof system that's going to have the heavier or higher wind uplift resistance. Some PVC systems and KEE systems can get pretty high wind uplift, but the modified bitumen typically will outperform, especially in the hurricane areas. I've also done a couple where we've put full paver systems on top of those roof systems to provide additional protection for the chemical exposure and for the falling debris type of, if you're in an area where you've got a lot of processed debris that might be falling on that roof.
Yeah, and just to kind of touch, with some of those heavy chemical resistance materials there, we'll kind of reach out and work with manufacturers as well and provide those data sheets. And, hey, let's make sure, this membrane's compatible. It's going to provide a long long-term solution for you as well.
Mr. Bryan says, is there a membrane that can work in all environments? That's a tough one, Mr. Bryan. I would say that there's ways to make almost any membrane perform in any environment, but whether those compromises or those caveats are going to be the best performance that membrane can do is questionable. So if you've got a highly caustic environment, you're going to want to choose something different than if you have a frozen environment. I don't know that any one system can meet all the criteria. Mr. Andrew asks, can a nuclear survey show if a metal deck needs to be replaced? I honestly don't know. I will have to follow up with we actually subcontract for our nuclear surveys. We don't perform them in-house, but I would be happy to follow up on that question to find out more about whether it can show if the metal deck needs to be replaced. I'm not certain. We've got one other here from Mr. Eric. He's heard that hiring a consultant means that you're going to get a Cadillac system. What if you don't need a Cadillac roof system?
Yeah, I don't think that comment's necessarily true. Kind of what Jennifer touched on earlier, the essence of consulting is really just coming up with a solution that meets the client's needs, and that part is a collaborative process. Sometimes these needs include staying within certain budgets or client requirements. Sometimes it's a need for a chemical resistance, as mentioned earlier, or resistance to foot traffic. There isn't really a one size fits all. So I think on each project, you really have to determine what are the owner's goals. Is it a retail space? Is it a warehouse, operating room? All these different scenarios have unique conditions. Another item to consider is how long does the owner plan to have the space? Are they leasing? Are they renting? Are they going to sell it? It should really be reviewed prior to moving forward with the design.
Yeah, and our job as a consultant is to understand your goals, to understand those goals and match them with the requirements from the code and from the insurance companies. So if we are doing our job right, you're going to end up with your own Cadillac, whether it's a Volkswagen Cadillac or whether it's a true Cadillac, but you're going to end up with the right fit for your project. That should be our primary focus and our target. Mr. Bryan asks, in hurricane zones, how important is it to have a tested edge metal system? I could say we do a lot of our projects for FM Global insured clients, and FM Global recently, within the last 5 years, made it a requirement to include pre-manufactured edge metals. And those pre-manufactured edge metals have a different type of testing than the traditional ES1 type of testing. So if you look back in the history of edge metals, ES1 testing systems were kind of the baseline and have become the standard for how edge metals are supposed to perform. But there's a lot of variations in the way that contractors can bend those or break those edge metals in their field shops, and those field shops vary. Sometimes you'll get Chester who does it one way and Sean who does it a different way. So there's a lot of variation, and it can all still meet that ES1 rating. Whereas pre-manufactured metals, those metal shops have a different level of testing criteria that they go to. It's a little bit tighter, a little bit more stringent. There's a little bit more quality control on the manufacturing side of things. You can get some higher ratings with pre-manufactured metals. You also can get some full system warranties that include the pre-manufactured metals. So that's something to consider, that the actual membrane manufacturer will provide you with a full system warranty that might include the edge metal components, which if you look at the wind being the primary cause of failure, edges are our primary point of failure for roofs, edges and penetrations. So incorporating that edge metal into your primary roofing manufacturer's warranty is really smart. All right. We still have time for a couple more. I think so. We've got one from Mr. or Miss Alley. Do you have a ballpark cost per square foot of various type of roof systems you've discussed for a typical industrial building? I'd like to circle back with you because it varies considerably across the nation. I got caught unawares in Colorado recently. It was 30 or 40% higher than I expected in Colorado. We do price projects across the nation in Canada and Mexico. So we've got some good pricing data that we can help to set some preliminary budgets. We would also caution you, if depending on which stage of the project you're in, if you're going for capital funding, we would urge you strongly to have a contractor proposal in hand before you turn in a funding request. But if you're looking at preliminary budgeting and financial planning type long range planning, we're happy to help with that and would like to circle back with you.
Yeah, and to kind of comment on that, there's just so many different variables. What's the height of the building? What's access look like for removing debris, getting material up on that roof? What perimeter detailing, there's just, can it be recovered compared to replace? There's just so many different variables which can affect that price. And similar to what Jennifer mentioned, I had a project 2 hours away, completely different scope, come in at a similar price, and they were just opposite ends, as far as, what the scope of work was. So it's really hard to determine that cost sometimes.
Yeah. All right. James, do you see any other questions? I think we've gotten through most of them. And do you have any others on your screen?
Yeah, well, we have let's see, we have one here from Brian, as far as different membrane thicknesses and how do we determine what thickness to utilize?
I think it has to do with hitting that target for the client. So what's the goal of the project? If the goal of the project is a 10 or a 15-year roof system, that's going to different thicknesses of membranes and systems can perform for different longevities. And so we look at that in terms of determining what is the roof expected to do and for how long is it expected to do it. So a 60 mil single ply membrane might last for 20 years easily. If you go up to an 80 mil, you might be into that 25, even possibly 30 years with the right maintenance program. And so looking at the target of the client and looking at what is the client's goal for this roof system really helps us to pick the right thickness of the membrane and the right system components for the membrane.
Yeah, and kind of looking at the mode of failure for that typical membrane, if we're typically seeing delaminated seams as a failure mode, maybe going to increased thickness isn't providing much value unless we have, that increased foot traffic that we're trying to prevent. So sometimes, adding thickness to the membrane isn't really a solution to every issue.
Yeah, sometimes just going to the thicker membrane isn't going to actually do anything for you in the long run of that roof. Mr. John asks, what's the most labor-intensive roof type installation? Well, I can tell you, built-up roof systems were the most labor-intensive roof systems that we've talked about today. It's one of the reasons that they're not as common in the marketplace. Although up in Canada, they are still the most common roof system for industrial properties, food manufacturing properties. The built-up roof systems are, every component is labor in the field. It's not prefabricated in the factory other than the felt sheets. So if you can imagine the application time and the time on the roof for those applicators is much more great on a built-up roof system. In terms of the other roofs, I would say you've got single ply is the quickest and easiest to install, especially a mechanically fastened single ply is definitely the fastest to go down in the field. I would say followed shortly by liquid applied membranes. They go down extremely fast.
Yeah.
All right. Well, we sincerely appreciate your time today. We're going to wrap this up. If we did not get to your question or if we somehow skipped your question, we will circle back with you. And as I noted to a couple of folks, we will circle back with some answers to those questions that put answers to the questions. Sorry, getting tripped up on my tongue there. Thank you again for your time today, and we genuinely appreciate it.
Thanks, everyone.